Lecture 12. Measuring acceleration. Acceleration is defined as the rate by which the velocity of an object changes. The velocity of an object changes when a force is applied to it. Acceleration is quantified by a direction and a magnitude. Direction is the way to which a force is directing the object, and magnitude relates to the strength of the applied force. Acceleration is described by Newton's second law. Having the ability to measure acceleration is very useful. For this purpose, we use an accelerometer. An accelerometer measures the force that is applied to a small test mass. This test mass is placed inside a device and is held in place by one or more springs or something equivalent. As gravity or other forces are applied on the test mass, they make it move towards a particular direction. The device measures the distance this mass travels from its resting position. The longer the distance, the stronger the force. Imagine the accelerometer or yourself in free fall. The test mass, as it's falling, is feeling no force being applied upon it. In a free fall situation, the accelerometer would report no acceleration at all. We use accelerometers in cars to detect collisions and deploy airbags, or to gather performance statistics. Accelerometers are embedded in smartphones to provide orientation information and for making games that are played by moving a controller device. You could use one in a toy car so that the car's wheels stop spinning if it has turned over, or to make toys that react to the movement of a controller in 3D space. Accelerometers are also part of inertial navigation systems, INS, that help vehicles like ships, planes, and cars maintain knowledge of the location when other positioning systems like GPS are not available. In our experiment, we will use a common 3-axis accelerometer, the ADXL335. It is a very cheap and common accelerometer. You can find it on eBay for about $7, and it's very easy to connect to the Arduino through any of its analog pins. It reports acceleration in 3 dimensions, x, y, and z. It's very robust, and it can detect forces of up to 10,000 Gs, where 1 G is equivalent to Earth's gravity at the surface. The circuit we'll put together contains the Arduino, 5 jumper wires, and the ADXL335 3-axis accelerometer. The sensor takes 3 acceleration measurements for the 3 dimensions. The Arduino reads the analog outputs 0, 1, and 2, acquires the measurements, and prints them out to the monitor. One thing to be very mindful about is that this device requires 3.3 volts input, not 5 volts like the rest of the experiments we have done so far. If you provide 5 volts to this accelerometer, you're actually going to damage it. Let's have a look at the assembly. Connecting this accelerometer to the Arduino is very easy. All you've got to do is to use 5 wires to connect the 5 pins from the device to Arduino's power, ground, and 3 analog input pins. So just plug it anywhere on the board. Then use the red wire to connect it to the 3.3 volts power. Black wire for ground. And yellow, orange, and white for X, Y, Z to go to Arduino's analog 0, 1, and 2 pins. With the wiring complete, we'll plug the Arduino into the computer and upload the sketch. And here's the output. As I'm moving the assembly up and down just looking at the values that are produced by the accelerometer. And this is the sketch we've uploaded to the Arduino. It's very simple. We have not seen the analog read function before, but I'm sure you can guess what it does. It reads the voltage present at one of the analog pins. The accelerometer outputs voltage to its three outputs relevant to the forces applied to it. For example, at rest, the reading of the z-axis is around 410. If I push the device upwards, I apply force along the z-axis, which makes the test weight inside the accelerometer feel heavier, and the voltage on the Z pin increases, causing the reading to increase. For example, in my case, it went up to 470. If I push the device downwards, the opposite happens. By taking and evaluating measurements in all three axes, you could make it possible for your device to know the precise direction of its movement and the force applied to it. And that's how you can measure acceleration in 3 dimensions using your Arduino. As always, before moving on to the next lecture, please make sure to attempt the quiz questions for lecture 12.